Sorry, I was having such good luck with videos, and now a couple in a row we've had phone calls and things messing with my internet. So sorry for the interruption in the last one. I'm not even sure where I left off, but what I want to emphasize is this classic, what I'm going to call butterfly shape. This is the classic magnetic field of a bar magnet. What it emphasizes is that the field lines always point out of a north pole and into a south pole. Just the way magnetic fields work, the lines get a little bit more concentrated near the end of the magnet. That tells us that the magnetic field is a little bit stronger at the end of the magnet, at both ends of the magnet. This would be kind of like looking at that wind vector diagram we saw at the beginning and being able to look at it and tell by the lines where the wind was strongest. Because these lines are bunched together at the end, that tells us that the magnetic field is stronger at the two ends. Since there's not a lot of lines near the middle of the bar magnet, kind of in this region, that tells us that the magnetic field is rather weak in the middle of a magnet. If you've played with a bar magnet, you maybe remember, maybe you have a bar magnet, you can try it out. If you're picking up paper clips, they don't really stick to the middle of the bar magnet, they always stick to the ends of the bar magnet. So to wrap it up, the good news is we're not going to do any math or any equations in grade 11. We'll circle back and do it in grade 12. But the sum up magnetic fields, they're a little bit more complicated. We're going to go with the model that magnetism is due to these internal dipoles being lined up. Some objects, the dipoles are lined up and lined up. We call them permanent magnets. Other objects, they're permanently or they're locked in a not lined up orientation, so they're permanently not magnetic. And then we've got some objects that can become a magnet when a permanent magnet is nearby, and then they go back to being a non-magnet when the permanent magnet's not nearby. So they can flip around. Magnetic field lines outside of a bar magnet always point out of the North Pole and into the South Pole. Next lesson, we're going to do a little bit on electromagnetism. And then this phrasing is kind of important. Outside of a bar magnet, they point from north to south. We'll come back to that in the next lesson. If you haven't done so, there's a few electric field questions here that you can practice those equations. And the check-ins related to electricity, this is the same, links to the same document that I put in the electric part. Email at any time if you have any questions.